Welcome back. This is the second video of the first module. Those of you that are paying attention, remember that during the first video, we talked basically about how you can draw a parallel between learning a foreign language and learning GIS, and about how learning GIS, which is what this course is all about, involves a lot of working with the terminology, working to understand the concepts associated with spatial data, and putting that to practice using the software. So it's kind of a three-component course. So today we're going to move on to some of that vocabulary, some of that terminology. First, what is a system? Well, a system, I'm going to tell you what a system is. It's a collection of components that work together to accomplish a task. So when you look at that definition, you see there's some pieces to the definition. It's a collection of components, so it's more than one component. And somehow those components don't work to their own ends. They work together to accomplish a task. So what a system produces in one way or another is generally somehow more than what is input into the system. Collection of components working together to accomplish a task. So I'm going to draw a graphic here. I'm going to make a collection of components. First I put 5 different components in there, and then I collect them by drawing this line around them and closing that line. Everything that's inside of that line I'm going to call the system. So that's what a system is, collection of components. Everything that's outside of the system I'm going to call the environment. The thing that separates the system from the environment is the boundary. So those are basic concepts of systems: collection of components, boundaries, environments inside the system. So for a system, some type of input comes into the system. This would be what's called an open system. An input comes into the system. The collection of components within the system works on that input, and it produces an output. So there you have it. That's what a system is. A bunch of stuff that works together to somehow convert an input to an output. Okay, so what's an information system? Well, it's a system, right? It's just an information system. So it's going to have a collection of components. It's going to have a boundary. It's going to have an environment. But what an information does is it brings data into the system, and it produces what's called information. So an information system converts data into information. So as a system, it needs to be a collection of components. So what are the components that are associated with an information system? Well, there are 5 that we're going to talk about. There's hardware, software, people, data, and processes. Right? So there's a lot of components to this information system. And what you'll be doing in the lab is you'll be using software and hardware to work on that data. The lab procedures and processes will involve stepping through how to convert that data from the into information. And the people are you working in the lab. Sometimes it's a group of people, so sometimes these systems involve a group of people working with the software and hardware to convert that data to information. So that's what an information system is. It's the same as a system. You can just be more specific about what the components are, what the inputs are, and what the outputs are. Okay, so what the heck? This information system somehow converts data to information. What's the difference? Well, you can think of data as just a low-level fact. The number 6 is data. What does that mean? I mean, what does 6 mean? It doesn't really have any meaning, but it's a fact. It's 6. It's a piece. It's an atom of data. If somehow you put that number or that piece of fact into context, you'll be able to use it as what's called information. So 6 might be the number of minutes I've been spending talking about systems. And so now the 6 doesn't just mean 6, it means something more. So I've associated context to that data, and that becomes information. So what the information system does is it takes in the data and it assigns context of one form or another to that data and produces information. Now that information is going to be way more useful to you than the data. The data doesn't mean anything. 6 doesn't really mean anything. But maybe the information about it taking 6 minutes to go through to this point in the video does mean something to you. So information has more meaning than data. And you can continue to process the information into what's called knowledge, and then over exposure to knowledge and time, you can make that into wisdom. So there's kind of a hierarchy that goes from data at the low level to wisdom at the high level. So here's the hierarchy, of course. Data's at the bottom. Those are just facts. Somehow you assign context to those facts and it becomes information. So that's what the information system is going to do. It's going to move you up the hierarchy. Eventually, hopefully, you'll get to the point of knowledge about whatever it is that that information represents, and after even more time and processing, you may get to the point of having wisdom. So it moves up the hierarchy with increased abstraction. Okay, so we know what a system is, we know what an information system is. What the heck is a geographic information system? Well, it's a system, collection of components. It's got an environment, got a boundary. It's an information system, so it's converting data to information, but it's going to have some components: hardware, software, people, data, and processes, because it's an information system. So what is a geographic information system? Well, it's an information system where the information has something to do with geography. So one of the basic definitions of geography is the study of the earth and its features, location of living things, humans, and their effects. So a geographic information system is a system that processes data, produces information, and the data and the information that a geographic information system works on have something to do with geography. So if you think back to the first video, what it is an information system where geography matters, where it makes a difference where. So that's all a geographic information system is. But it's also hardware, software, people, data, and processes. Here's the hierarchy. I put that information system inside of the hierarchy where it fits. It takes data and it produces information. It has hardware, software, people, processes, and data. If it's a geographic information system, it has something to do with geography, makes a difference where. If this information is useful over time and over use, the information becomes knowledge. Once a person has gained knowledge, then they can take the step according to the hierarchy to feed back into the information system and eventually get to the point where you have wisdom. So that's the goal of these things. Okay, here's an aside. I'll try not to spend too much time here. This comes from your book. It's talking about GIS hardware. I'm not quite sure. I don't remember what chapter it's about. But when this book was written, this hardware was kind of state-of-the-art, cutting edge. You can see that there are things like in the upper left corner, a table digitizer, and there's a plotter over on the right. There's a big server machine in the lower left that has a local area network connected to a big desktop. Well, some of you will be working with this stuff if you go out and work with it. Some of you will work with it in the labs or at school. But really, when you look at this, you can see that it's kind of dated, even at this point. So one of the issues you run into with texts and with chasing the technology is it's always evolving. So I can tell you about the way things were 10 or 15 or 20 years ago or even 2 years ago, but that's really not going to help you 2, 3, 5 years from now. So here's another picture from the book. It has an iPhone, and I'm sure that when they wrote this book, they said, this is really cutting edge. We're going to show these iPhones and these apps and what they can do. And I don't really know about iPhones because I have fallen off the curve of gadgets, but I don't think that's an iPhone 6. Is an iPhone 6 better than this iPhone? And 5 years from now, what will an iPhone look like? Will there even be iPhones? So you make sure that you don't focus on the current technology. You need to use the current technology to get the job done. But what's more important is to focus upon the vocabulary and the concepts, because those are going to persist throughout time. Concepts that apply now will apply in the future. Hardware that applies now may not have anything to do with in the future. Here's another graphic that does this, and I will try not to spend too much time on it, but I've been in this hardware side of the game for a really long time. I didn't start at toggle switches, that was before my time, but computers used to be toggle switches, and you would manually flip switches off, on, and that would create what's called a binary code, and you could use that code to process data. Then there became this thing called the keyboard. Never used to be a keyboard. It was a wonderful innovation. The keyboard would allow you to press something and it would send the entire code, not just toggle switches. Then they made these things called F keys on the keyboard, the thing that's on the top of that antiquated keyboard where you can push one button and it accomplishes a bunch of things at once. Then they had these things called menus, and that's when the interface, when the hardware started becoming a little bit graphical, so you could actually do things besides just typing in on one line of text. You could use menus to pick things, and it was a major innovation again. Not only was it making it easier for the people that were already in the business, it was making it easier for new people to come into the business and process the data into information. Icons, great wonderful thing. Graphical user interface, the GUIs, Windows and Apple came up with these things that were actually graphical. You could see a smiley face on the screen. I don't know how you would type a smiley face. Right now, we're kind of at a place where there's voice, right? And voice recognition isn't perfect yet, but it's here. I mean, those of you that have iPhones and use Siri know that Siri works pretty well, but it's not perfect. And so voice is where we're at right now, and theoretically, in the future, it's going to become thoughts. So voice needs to get to the point of Star Trek voice, where you just talk to the computer and it understands what you're saying all the time. And that's a major jump that hasn't been happening for probably 30 or 40 years. They've been working on that. At some point, theoretically, in the future, you'll just be able to think it, and the computer will take care of it. That's kind of a scary proposition, and I'm not going to cover any of that in this class. But if you focus on the current set of hardware, you're going to have a trouble when the world evolves into another process. If you focus on the concepts and the vocabulary, that's going to persist. Okay, enough with the systems. One of the things that you learn really quickly in GIS and probably in many types of disciplines is reality is really complicated, right? And every time I look at this graphic, I swear I look at the left-hand side and there are 4 of those things. I look at the right-hand side and there are 3 of those things. I can look at it 1,000 times and it's always that way. So what is it really? Is it 4? Is it 3? I don't know, but it's complicated. That's for sure. So reality is complex. So we've got this really complicated thing called the planet. It's really complicated. It's complex. So how the heck are we going to put that world into this information system? And the information system is hardware, software, people, processes, and data. How are we going to jam all of the world into that computer? Well, that's really going to be complicated. How are we going to do it? We're going to use what's called a model. So we're going to use a model to somehow represent all that complexity, or as much of that complexity as we can, in the computer, and use the computer to create data and move that data into information. So what's a model? This is not what I'm talking about. That's not the kind of model I'm talking about. I'm not talking about this kind of model either. I'm not sure how many of you know who that is, and I can't remember his name. I always have a problem with his names. It might be Marky Mark, or I'm not sure what his name is, but you all know who that is. But it's not this kind of model I'm talking about. What kind of art is this? Some of you out there will know that that's probably classified as abstract art. And so that's abstract art. Well, what makes something abstract art? I don't know. It must be that it's an abstraction. Well, what the heck is an abstraction? Here we go out to the internet again, and I find the definition of abstraction. And abstraction is a process of formulating generalized ideas by taking pieces from reality. So when I look at this abstract art, is there any way that that could be representing some piece of what here is an image of reality? Could somehow what's on the left be an abstraction of what's on the right? Well, in this case it actually is. The title of this piece of abstract art has to do with the Palouse Hills. So what you're seeing there are fields on the Palouse, and it's an abstraction of the reality that is the Palouse Basin. Okay, back to what's a model. A model is an abstraction. of some piece of reality. Okay, that's okay. You understand what abstraction is, and that kind of works. It's a piece of reality. But I don't really like that definition very well. What about this definition? A representation of some phenomenon of the real world made to facilitate an understanding of its workings. Oh my gosh, look at the number of words there. That's either somebody who's getting paid by the word or maybe it's an academic. But I don't like that one either, because how the heck am I going to remember that? But there's one that I kind of like, and it's this one. A model is a simplified and generalized version of real entities or events. So think of that. A model is a simplification. It's a generalization of reality. So you can think about it as taking a piece of reality. It's the piece that you're concerned with and focusing upon that piece. But also think about what happens when you make a model. You're only taking a piece of reality. And when you work with the GIS, you have to continually remind yourself that the GIS is not reality. It's only a piece of reality, and it's the piece that you think is the most important piece to tell your geographic story. So that's what I'm going to call a model. So what did I talk about in this lecture? Well, I talked about what is a system, what is an information system, what's the difference between data and information, and then what's a geographic information system. So once you get a handle on what all that system stuff is, then we're going to talk about what's a model. Okay? Next time, the next video will cover models that are used in GIS. So you'll be able to understand which pieces of reality a GIS takes to make its information system and which pieces maybe that it leaves out. So that'll be next time.